Hey Jeb, boom, right? Yeah? Been to Gainesville, Florida? Anybody? It's hot. They serve alligator. It's delicious. But it's a college town. Maybe it's liberal, maybe they hate Jeb. So let's forget politics and analyze it statistically. Grab a template. Let's go through this. Grab a template and go through this. Is Jeb still governor? Is he gone now? This is 5 years. So I'm thinking he might even be out all. Or for president. That doesn't surprise me. Keep the Bush legacy going. Okay, so first of all, what parameter are we testing? Now there's two ways you can answer this. One is to look at the 3 words in the before the data set, because I told you. But the other one is to think, how did you know that by reading the actual article? What is all over that article once you get into the numerical part of the article? Because this is, Linda, this is related to a question you asked earlier. How do you know, you get in there, and how do you know how to start? Well, you start by looking at the kind of data you have. What kind of data do you have in there? You got a sample, right? You've got a sample of 402 dead people in 2009 from motorcycle-related injuries. Good. You don't have a sample from 1999. All right, I couldn't find one of those, but I didn't have to find one of those because instead I found something better. I found the Florida motorbike death rate. That's what I found from 1999. It was 0.000745. Pretty small. Pretty small. But it's a rate. So how do I know what variable which variable am I testing? It's got to be a proportion because it's given to you, discrete data, given to you as either the data or proportions of the data. That's how you know. You analyze what you're studying and figure out what kind of data is it. What kind of data is it? It's discrete. Yes, it's discrete. So, circle P because we're testing proportions. Now, we have to define that variable as well. We have to define that variable as well, little p. I guess this is step 2 on your template, yes? Okay. So, what are we interested in? Why are we reading this article? What proportion are we interested in right now? Nick, you've already started us down this road. What do you guys think? Let me see some ideas. What proportion are we interested in? We have 1999's Florida motorbike death rate. Kendra?
The deaths per people with motorcycles.
In what year?
1999.
We have that one. We want to know what it is in
2009.
Boom! That's why we're reading the article. We knew what it was 10 years ago when the riders had to wear their helmets. Remember, they had to wear their helmets in 99. But then Jeb said, it's okay not to wear your helmet anymore. And we're going to try to see if that means statistically significantly more people are now dying because they're not wearing helmets anymore. Does everybody follow that logic? This is kind of, if you can get through this, the rest of the test should proceed fairly straightforwardly, if that's a word. So we got to define it. We know what the proportion was back in 1999. Let's compare it to this one. Yeah? Let's compare it to this one. What this is now the Florida. I'll just do the rate of death. Ooh, that's terrible. It's like a metal band. The rate of death on Florida motorbikes in 2009. The only difference, of course, is that 1999 and 2009, assuming everything's the same, the only difference is they aren't wearing helmets now and they were then. That's an assumption we have to make because we can't control the other variables. We'll talk about that briefly. Cool. So I'm going to add a curve. I didn't think I mentioned this. The way I set this template up, I left a little space here next to step 3. That's to allow you, if you want to draw the null curve in and kind of sketch out what we're doing in class. I didn't want to draw a curve on there because I wanted you guys to be able to draw it however you wanted to see it fit. So I'm going to draw this curve right here, and we got to put a 0 there, of course. Now this is the null curve. We'll come back to that. Let's set up our hypotheses first. Let's set up our hypotheses. So our null and our research. This newspaper clearly has a research hypothesis, doesn't it? It clearly has an agenda that it's trying to sell us. So let's see if we can support it. Not the biased way, in a statistical way. What's the research hypothesis going to be, friends? That there's more deaths, there's a higher rate of death. Can I say it that way? If I say more deaths, and I'm actually not looking at a percentage, but let's say a higher rate of death, yes? And this is important, thank you, Danielle. It's important to know when to use which. And I'm not talking about just now, I'm talking about in general when to use which. As I go through negotiations right now, I'm realizing that sometimes nominal values, the whole number of values are important, and sometimes looking at the percentage effect of a nominal value is important. So it's good to bring that up. In this case, it's percentage. And we kind of have to. We'll come back to that momentarily. So what was the percentage of rate of death In 1999?
0.000745.
So the claim is right now that the rate of death of Florida motorcyclists is greater than 0.000475. So what's that? 0.0475%.
745.
Oh, 745. Thank you. 745. Thank you. Keep me honest up here. Okay, that's the paper's claim. This was back to your question too, Linda. What's the opposite of that claim? Or good. It's either less than or it's equal to that number. Now, I'm going to throw this out there once, and this is just for you to hear once, and you can ignore it if you want. In research articles, I love the fact that you guys are going to write P is less than or equal to that. Very often, all research articles will simply put an equal sign there. I don't know what it is. It's a laziness or just not. People don't like mathematics anymore. Sometimes they'll just put an equal sign with the logic being that it's the opposite of this. I don't like doing that personally. You guys like it, seeing the opposites? I do too. Because what's the opposite if it got bigger? It got smaller, or it stayed the same. Yeah, it's got to have the two. There's got to be two things in one of them. Like yesterday, the two-tailed test. The two things were here and the one thing was here. Well, the one-tailed test, there's one here and two here. So that's why I like having that. I want to throw that out there in case you see, for example, a research article where this is greater than that's equals. As mathematicians, you're going to be like, that can't be right. There's got to be another sign in there somewhere. There is. They just don't write it. I don't know why. I like having it this way. Cool. All right. So let's go to our null curve real quick, and let's add our numbers to it. And let's see if we can figure out where we're trying to see if we lay on the curve, yes? So this is 0, because we're going to standardize our result, a test statistic. What percentage does it correspond to? Good, look over there. That's why I had you write them down, so you understand. Go ahead, nice and loud.
0.00.
Yes, ma'am. That corresponds to that 0, because you know that was the old Florida motorbike death rate. Now, we don't really know what the shape of this curve is because they hid that data from me. Doesn't matter. I know it's a bell curve because of the central limit theorem, and I know it's centered on that average. So that's all I need to know. If the paper is correct in its claim that now the motorbike death rate is off the charts higher, where should our rate land? Just give me a point, not a number right now. We'll get precision momentarily. Get point where it's going to land if the paper is correct. Good. Well, think about it. Look at that as an arrow. That way. That's why you said that alligator thing in class. Forget the damn alligator. That's an arrow. Think of it as an arrow. It's going to land this way. It's going to land this way. Does that make more sense? Yeah, the alligator was confused the hell out of me. It's the bigger number. I'm like, yeah, but the arrow. Yeah. So somewhere out here, and I don't exactly know where. I mean, we could figure out what test statistic it has to exceed. But we're going to see if it lands somewhere out here in the less than 5% region, right? That's the idea. If it lands to the right of that green line, which is, I think it's positive 1.645, I think that's the cutoff. Not important because the TI will tell it to us. So if it's extreme enough to land in that region, then we know the article might have a point to its headline. Of course, we should always go back and replicate the study to see if it's not an outlier, but at least it's a start, because what did Fisher teach us about the 5% p-value? What does it really mean?
Need to do it again.
Take another look. Do it again, take another look. But at least it's a start. Okay, so anyway, we now have to talk about the errors that we could possibly make. Is everyone okay with this so far? So far, hopefully, so far. Okay, let's talk about the errors. Before we even do the tests, what are the two types of errors, type 1 and type 2? What would type 1 error be in this case? If we made one. I don't even know if we're going to make one. Yeah, we might make one. What would a type 1 error be? Go ahead and call it what we used to call it 243 first. It's a false positive. So that means...
You say it did go up, but it actually didn't.
That means you say the Florida motorcycle death rate actually did go up. But it didn't. You said something changed. You said it went that way. You said, I'm sorry, it doesn't come. You said it went that way, when in fact it's either here or this way. Good. That's a type 1 error. We could make that if we get what kind of a p-value? We could get a type 1 if we get what kind of a p-value?
That's larger.
Start making this connection now. We could get a type 1 error if we get what, big or small p-value? A couple votes for small, that's exactly correct. You'd have to land out here to get a type 1 error, wouldn't you? That means a small p-value, less than 5%. Just put that in the back of your mind. We're going to see that every day for the next 4 weeks together. Sorry, not to make it seem terminal, but Cassie's like, excellent. So glad. And the same bad jokes from 243. So, type 2, false negative. Okay, we could make that theoretically. So, let me ask you what a false negative is in this case. Now, Danielle, tell me what a false positive was one more time, nice and loud.
When you say that the rate has gone up, but it actually hasn't.
Awesome. So, using that as a model, what would a false negative be? McKinnon, go!
Saying it didn't go up when in fact.
Saying it didn't go up when in fact it did. All right, that's the false negative. Type 2, false negative. Everything's fine. Nobody's dying at any higher rate. Oh crap, they actually are. We just missed it. And this goes back to the idea of replication of a study as well. You very rarely see negative test results published. Oh, by the way, just by the way, snorting coke before job interviews, not a good idea. Well, maybe it is. And your study missed it. Oh, sorry. Not condoning any kind of illicit behavior. But the point is you very rarely see negative test results published. Why? Because that's the way the system works. It's unfortunate. It's not a good thing. But false negatives can be wrong as well. So my next question is, which one do you guys think is worse? Saying that it's worse when it isn't, or saying more people are dying when they're not, or not saying they're more dying when they are? We got to vote for type 2 over here. Type 2? Lots of type 2. Type 1? Okay, good. Let me hear arguments for both. And this is, again, you got to realize this part of any template is your opinion. So give me a type 2.
Well, because if it was actually going up, then they could possibly change the law back and start saving lives.
So there's one good argument. If the rate actually is going up, so if the curve is over here, but we thought it was over here, which means it's actually significantly higher, if we can identify that, maybe we found a variable. Maybe the variable of wearing a helmet is meaningful, and we missed it. So that's good, good. That's one good consequence of making a type 2 error, false negative. A bunch of you said type 2. Do you have similar arguments for why type 2 was worse? Because people are dying unnecessarily, maybe? I'm guessing that's paraphrasing what you're saying, Danielle, a little bit. You guys okay with that?
Yeah.
Mel, please, type 1, tell me.
Mine's not really statistical. I just think
It's okay.
it's kind of politically driven to say something that's not true.
Yeah, especially if you were goofed in your study. Yeah, to make a claim. Now, false positives, you've often heard it's better to err on the side of caution. That's a false positive, right? It's better to err on the side of caution in a case like this, where we're reinstituting the law would theoretically, at least in theory, be safer. Logically, you'd think having a helmet on a motorcycle is safer than not having a helmet on a motorcycle. What's interesting is 2 days ago, a former 243 student sent me a study, I haven't read it yet, where it's statistically supported that riding a bike without a helmet can be arguably safer than riding it with one. So I wonder exactly, I thought the same thing, I'm like, really? And the first couple lines, I haven't read a chance to, I can't wait to read it, it's so fascinating looking. The first 2 lines say, first of all, I'm not condoning going out and bombing down downhill trails without a helmet. But this author is looking at the overarching riding of bicycles in America. And the argument I haven't gotten to yet is why you shouldn't wear a helmet, why it might make you safer. But his claim somewhere in there is if you are in a collision where your head hits the pavement, obviously you want to have a helmet on versus not having a helmet on. But his argument, I'm guessing, is going to be that in many, many, many accidents, your head doesn't hit first. In which case a helmet really doesn't do anything. I've been riding a bike for 30 years, I've been commuting for 20, I've never once, knock on wood, taken a header. I crash constantly on trails, and I crash occasionally on the road, but I never go head first. I fall kind of like a twisted cat, and I get something down before my head. So I can't wait to read the rest of the article to see where it goes with that. The only statistic graphic that he's given me so far is percentage of injuries by vehicle type. There's cars, there's bikes, there's pedestrians, there's pedestrian bike accident injuries, there's pedestrian car accident injuries. Bikes are a very small sliver of that pie overridingly because there are so few bikes on the road. As a percentage, this is not nominal, this is percentage-wise, go back to your point, Danielle. So cars make up 54% of head injuries. Cars and pedestrians, I believe. Spikes aren't even on the radar as far as that goes. I can't wait to get into it. So again, coming back, I'm trying to tie this back to what you were saying, Mel. Same idea. If you're err on the side of caution, it could just be politically motivated to make Jeb look bad. Or good, depending on which side you want to be on. Di, yeah.
I just want to know when you wear the helmet, does it impede your hearing at all?
It shouldn't. Oh, I'm not wearing like a full face, full head
Well,
helmet.
I mean, in general, when bike riders wear helmets, does it affect their being able to
Shouldn't.
wear what's around?
Well, that's one of the things I want to see if he quotes on, because maybe having the helmet on your head impedes turning around and things. Right, that could be an argument in favor of not wearing it.
On a motorcycle, it's like it gives you blind spots.
Well, probably because they have to cover, unless they wear those little tiny military, like cute little helmets with the spike on the top, because your ears aren't covered then, and you can actually turn your neck. But like my son had to get a BMX helmet. He started racing BMX a couple years ago, and he's got this full face with it's like a shark. It's actually got a shark painted on it, actually. And I'm like, oh my God, it's heavier than he is. Maybe his head's safe, but he's causing spinal damage later in life because he's wrapping his head around like this. So good points. Maybe he touched on that in the article. I can't wait to read it in the article. Okay, good. So you pick type 1, type 2. You decide which you think is worse and why. You cannot be wrong. This is part of research methods, is knowing which one you want to avoid more. So if you think type 2 error, oh, this is great. If you think